Hello friends, let's do another question from CAET 2025. Let's read the question first and then we'll solve it. For the functions fx is equal to x power 2 by 3 and gx is equal to x power 4 by 3, consider the following statements. First one is f is differentiable at x is equal to 0. Second is g is differentiable at x is equal to 0. Then which one of the following statements is true? One only, two only, both one and two are correct, or neither one and two are nor two are correct. So to check for differentiability, the steps are first check for their continuity. If the function is continuous at that given x, and then we check the differentiability. Although some may assume that the functions is already continuous at x is equal to 0 for fx and gx, but we will check the continuity also. So fx is equal to x power 2 by 3, continuity at x is equal to 0. So for left limit, x tending to 0 minus x is equal to 0 minus h, which is minus h power 2 by 3, which gives me minus h into minus h square is power 1 upon 3, which is h square, a positive number, power 1 upon 3. H is very small number, so this is tending to 0. Now for right limit, x tending to 0 plus x is equal to 0 plus h power 2 by 3. Again, this is tending to 0. So the function fx x power 2 by 3 is continuous at x is equal to 0. Now I will check for differentiability. Okay. So f dash x is d by dx of x power 2 by 3, which will give us 2 by 3 into x power 2 by 3 minus 1, which is 2 by 3 x power minus 1 upon 3, which is 2 by 3 times x 1 by 3. Now when x is tending to 0 minus, or x is equal to 0 minus h, which is minus h, we get 2 upon 3 minus h power 1 by 3. This is tending to minus infinity because a very small number, negative number in denominator, power 1 by 3, it will still be a negative number and will tend to minus infinity. So left limit of differentiation is minus infinity. Now let's check for the right limit. So f dash x tending to 0 plus x is equal to 0 plus h, which is h. If I check for the, it will be 2 by 3 x power 1 upon 3. So it is 2 by 3 h power 1 by 3. A very small positive, small but positive number in denominator. It will be tending to infinity. So the left limit for differentiation is minus infinity and the right limit is plus infinity. So fx is not differentiable at x is equal to 0. Now we'll check for the other function. Gx is x power 4 by 3. Now for the continuity part, x tending to 0 minus x is equal to 0 minus h, which is minus h power 4 by 3. A very small number, power 4 whole power 1 by 3 is positive small number, power 1 by 3 is tending to 0. So yes, now let's check for 0 plus, or x is equal to 0 plus h, which is h power 4 by 3, which is h power 4 whole 1 by 3 again tending to 0. So x power 4 by 3 is continuous at x is equal to 0. Now let's check for differentiability. So h dash x will be equal to 4 by 3 x 4 by 3 minus 1, which is 4 by 3 x power 1 by 3. Now for x tending to 0 minus x is equal to minus h 4 by left limit of differentiability we are checking. Minus h power 1 by 3, a very small negative number, power 1 by 3, again tending to 0. It is not in denominator, by the way, okay? Now for the right limit of differentiability, x tending to 0 plus, x is equal to 0 plus h, which is h, 4 by 3, h power 1 by 3, very small number, power 1 by 3, again tending to 0. Okay? So left limit of differentiability is 0, right limit of differentiability is also 0. So x power 4 by 3 is differentiable at x is equal to 0. So the answer would be 2 is correct. By general rule of thumb, for a function x power n, if n is more than 1, it will be differentiable at x is equal to 0. If it is less than 1, it will not be differentiable. Okay, thank you.